What's going on, everyone? In today's video, I'm going to teach you about the quotient rule of exponents. So, in the quotient rule of exponents, if you ever look this up, you're going to see something that looks something similar to this, where if you're dividing two bases with different exponents, or even the same exponent, or if it's written like this, it might be written as a fraction, or it might be written with the division sign. Either way, you're going to see it equal to that base to the power of the difference in the powers. So what does that actually mean? It means that if we have the same exact base here, or here, depending on how it's written, you rewrite it so that way you only have one of those bases, and then your new exponent is just the difference between the bottom one and the top one. So whatever your top value is, you subtract it by whatever the bottom value is. And why is that? Well, if we look at a problem that's like 3/7 divided by 3 to the third, you can rewrite this as 3 to the 7th all over 3 to the third. And let me actually expand this. So 3 times 3 times 3 times 3. That's 4, 5, 6, and 7. And let me rewrite the bottom one. So it's 3 times 3 times 3. So I just expanded 3 to the 7th. So I have 3 multiplied by itself 7 times. And I wrote out 3 cubed, 3 times itself 3 times. And what I can actually do is I can actually start to cancel some of these out. So let me cancel this 3, this 3, this 3, and that 3, this 3, and this 3. And now I'm done. So there's no other 3's that I can cancel out here. And what am I left with? Well, I'm left with 1, 2, 3, 4 different 3's. So I now have 3 times 3 times 3 times 3. That is the same thing as 3 to the 4th. And that's also the same thing as 3 to the 7 minus 3. Okay, so I just took my base, rewrote it as the difference of the products. Okay, now let's check out an easy problem. So in our easy problem, we have n squared over 2n. So we can't really do anything with 2 right here. There's no coefficient on the top, so there's nothing we can cancel or use the greatest common factor to reduce. There's nothing we can do. We just got to leave it there. But I do have this n squared and then n to the power of, well, 1. It's just not written. And so let me rewrite this as n, and then I would then have one exponent minus the other one. And don't forget my 2. So I just rewrote this now with one of the bases, and then my new exponent as the difference in those powers. So 2 minus 1, what that is going to leave me with is, well, 2 minus 1 is just 1. So it's n to the power of 1 all over 2. That's my final answer. Pretty easy, right? Let's check out a median problem. All right, so here we have a median problem. So I say that I have negative 2mn to the negative 2, then negative 2m to the power of negative 3. Okay, so let's do this step by step. So I have negative 2 divided by negative 2. So anything divided by itself is positive 1. And that actually, that's going to just cancel that out for me entirely. So negative 2 and negative 2, those are gone. So now I have mn to the negative 2, then m to the negative 3. So the only thing that I have in common here is m and then m to the negative 3. So I can rewrite this as the one base, m, to the power of 1 minus negative 3 all over n squared. So why did I do what I just did? So remember that any exponent that's negative, if you put it from the numerator into the denominator, it will become positive. And then right here, I have m to the power of 1 minus whatever the value is of that exponent that's in the denominator there. Okay, that confuses a lot of people. Make sure that we're using parentheses to make sure that we're subtracting that entire value. So what is 1 minus negative 3? That's the same thing as m to the power of 1 plus 3 all over n squared. That's going to give us m to the power of 4 all over n squared. There we go. That's how we do that. Okay. Now we're on to a harder problem. So let's take a look at this and see how we can solve this step by step. So I have negative 4m to the negative 2, n to the negative 1, divided by m to the power of 3 over 2 times n squared. All right, so I have my negative 4 right here, but I have no coefficients or any numbers down here that I can divide by or use to simplify. So my negative 4 has to stay there. Then I have m to the negative 2 and then m to the 3 over 2. So let's rewrite this as one base, m, negative 2 minus that quantity 3 over 2. And then I have n to the power of negative 1 minus that quantity positive 2. Okay, so again, whatever is in the numerator, subtracted by whatever is in the denominator. It doesn't matter if it's negative or positive, just subtract the 2. So now that I have that rewritten, I can now rewrite this as negative 4. So then I have m to the negative 2 minus 3 over 2. So that's just subtracting fractions or adding fractions. It's just basic algebra with fractions and a whole number. So what I would do here is just add these two. This would give me m to the power of negative 7 over 2, n to the power of negative 3. So what I would do now is just most courses and most textbooks or most exams are going to want no negative exponents in your answer. So what I would do is I would take these negative exponents, move them into the denominator to make it so that they're positive. So if I rewrite this, I would now have negative 4 divided by m to the power of 7 over 2, n to the 3, and there it is. That's my answer. So there you have it. Thanks for watching. Let us know in the comments if you need any help. To be honest, we don't really have that many people watching, so you'll basically just get free homework help if you if you do that. Just like and subscribe, and hopefully you hit pause on some of the problems and try them out yourself. If not, we'll see you on the next one. Bye-bye.